Okay, good morning, students. So today we are going to continue the Lewis structure lab. And so the next one that we're going to go over is going to be this methylene chloride. The chemical formula is going to be CH2Cl. So let's get started on step one in the procedure. So step one is going to be finding those valence electrons in the molecule. And so to be able to do this, I made a table. That way I can see how many valence electrons are in each of them. So for carbon, let's look over here. We're going to follow the periodic trend, which is going to be 1, 2, 3, 4, 5, 6, 7. So if we look at what column something's in, we can be able to tell how many valence electrons there are. So for carbon, we can see that's in column 4, so that should have 4 valence electrons. For hydrogen, it's column 1, so it'll have 1 valence electron. And then for the last molecule, which is Cl, we can see that's in column 7, so that should have 7 valence electrons. Okay, so 4, 1, 7. Okay, great. So we're going to add those all together. So 4 plus 1 plus 7. However, we need to take into account how many of each atom there is. So for carbon, there's only one, so we don't worry about it. But for hydrogen, there are 2. So we need to make sure we count for all the atoms in the molecule. And then for chlorine, there's 2 as well, so we're going to times that by 2. So the total for this one is going to be, sorry, let me see. Let me break it down. So it's 4 plus 2 plus 14, so that should be 20. Okay, so now we have the total valence electrons. So total valence electrons. Okay, great. So let's go to step 2. So step 2 is trying to decide which of the atoms are going to be the central atom. So to do this, we're going to look at periodic trends and mostly electronegativity. So if we look at our periodic table again and think about which one's the most electronegative, so we're going to have chlorine, carbon, and hydrogen. So chlorine's going to be the most electronegative, so it's not as likely to be the central atom. And then we think about carbon and hydrogen, and the thing is, hydrogen can only make one bond because it only needs one electron to be stable. So carbon will most likely be in the middle because it can make the most bonds, and also it is less electronegative than chlorine. So in step 3, we're going to draw the bond, or we're going to make the bonds. So I'm going to put in my Cl, Cl, H, and hydrogen. So, and I'm going to make a bond to each of these. Now, the next thing I like to do is I do like to keep track of how many electrons I've used and how many are left. So on here, I used 2, 4, 6, 8, because there are 2 electrons in each of those bonds. So I just used 8, so I'm going to write 12 electrons left. So let's move to step 4. So for step 4, we are going to use all the electrons we have left over to be able to make lone pairs on the outermost atoms. So we're going to put them all on these chlorines. So we have 12 left, so I can put 6 on each of these. So I just used 6 for each chlorine. That means I used 12 in total, so there are 0 electrons left. So at this point in time, we're going to look at it, and we're going to make sure that each atom has a good amount of electrons. And so for hydrogen, we only need 2 electrons on that one. And as we can tell, we have one bond that contains 2 electrons. So this hydrogen should be very happy. And so over here, same thing. Now for chlorine, we have we have 3 lone pairs of electrons. So that accounts for 2, 4, 6, 8 electrons around chlorine. Thus, that one is going to have a complete octet. Same for this one. And now we're going to look at our carbon. So carbon has 4 bonds around it, as we can see here. And so for electrons, it's going to have 2, 4, 6, 8. So all of our molecules have a complete octet. So with that information, this is going to be our final Lewis structure. So using this, we will be able to determine the geometry of the molecule. And so I really like the table that's in the procedure. I think it's really, really helpful. So using that, I'm going to look at, the first thing to know is the number of electron sets. So we're going to look at carbon as the central atom and see how many electron sets are around it. So we have 1, 2, 3, 4. I'm going to number those. 1, 2, 3, 4. We have 4 different electron sets around it. So that means that our electronic geometry is going to be tetrahedral. However, to find out the molecular geometry, we want to find or see how many lone pairs there are. So we need to have, or depending on how many we have, if we have 0, 1, or 2, it'll change the shape of the molecule. And as we can see over here, all of them are bonds. There are no lone pairs on that carbon. So we're going to put 0. And so this one is going to be a tetrahedral. Okay. So now, following this, we want to look at the molecule in a 3D form. And so the way I'm going to do that is I'm going to show you guys this app called MolView. And this one shows our molecules in 3D, which is really nice, and we can draw whatever we want in here. So I'm going to erase what we have and draw the atom that we just did. So carbon in the middle, Cl, Cl, hydrogen, hydrogen, and then I'm going to make bonds connecting each of them. Okay, and this uses a Lewis structure from organic chemistry. So it's going to take off those hydrogens, and it's going to not write carbon, since carbon is the most common molecule in organic chemistry. We just kind of leave it off. So in 3D form, this is what it's going to look like. So as you can see, each of them are at a different angle. They're as far apart as possible. And then at most times, one's coming towards us and one's going away, as you can see with these hydrogens. That's going to be our tetrahedral shape. If we drew it as, if we connected them, it'd kind of be like a pyramid shape. Okay, and that's going to be it for our methylene chloride.